week we are featuring
There it is.
adding fractions. Isn't it lovely? Fractions.
Oh, adding them is hard though, Ms. Marino.
Yeah, well, let's see what we can do. Here's our first example. What is the sum of 2/3 and 4/5?
Wait, that doesn't look like an operation I know. What are you supposed to do to them?
And I don't know, I think the key word here is
Oh, yes. That means addition.
that so means addition. So I'm gonna put a little plus sign there so we can remember. So really what we're doing then is 2/3 plus 4/5. Can I just add them? 2 plus 4 is 6. 3 plus 5 is 8.
No, that doesn't work.
No, alright.
You gotta get
Erase that.
Yeah, don't do that. You have to make the denominators, the numbers on the bottom, be the same before you can add. You can never add until they're the same.
Like denominators?
Yes.
I think I remember something about this. Alright, here's what I like to do to make like denominators.
Okay.
I look at my denominators, in this case 3 and 5, and I pick the bigger of the numbers and I start skip counting. So 5, 10, 15, 20, 25.
This is a good idea.
So now I look at my other denominator, 3, and I'm gonna see which number does it multiply into evenly. So does 3 divide into 5 evenly?
No.
Does 3 divide into 10 evenly?
No.
Does 3 divide into 15?
Yes.
Then I circle that one so I remember. And now I know that these are going to be my new denominators. And we already figured out that we need to put a plus in between.
Okay. Now we have to make this fraction into a fraction with 15 in the denominator. So we can't change. Well, we can't change the value, right? It still has to be equal to 2/3.
Yes, it has to stay 2/3, but it's got to look a little bit different. We got to make an equivalent fraction.
I have an idea. You can always multiply anything by 1 and it stays the same, right?
But if I multiply 2/3 by 1, it's just going to be 2/3, because if you multiply by 1, it stays the same.
Watch this. How about if we multiply it by a fraction that is a number over itself, because that's equal to 1?
Like
A unit
4
fraction.
over 4 equals 1, 3 over 3 equals 1, like that?
Yeah.
Unit fraction, perfect.
Only we want, when we multiply fractions, you do just go across and multiply. So in the bottom, to get a denominator of 15, we're going to have to multiply 3 by 5. And to make it a unit fraction, like the ones you made over there, there'll have to be a 5 in the numerator as well.
Okay.
Now, I'm kind of doing this way, when you might ordinarily do it that way, but you just, for multiplication, unlike addition, for multiplication, you just multiply across the top and the bottom.
Okay, so 5 times 2 is 10, 5 times 3 is 15, and I can write a 10 for my first added.
Yeah, and this fraction, 10 over 15, is equal to 2 over 3 because we just multiplied it by 1 in kind of a tricky way.
Very cool. Let me try it for 4 over 5. So I'm going to move this down a bit. So 4 over 5, I'm going to multiply it times a fraction. And because I want to get 15, 5 times 3 is 15.
Mm-hmm.
And whatever I multiply the denominator by, I also have to multiply the numerator by. So multiply 4 times 3 gives me 12. 5 times 3 is 15. And we didn't change the value at all. 4 over 5 is exactly the same as 12 over 15. I write my 12 down here, and I now have an addition problem that I can solve because my denominators are the same.
That's right, and you can't add until they're the same, but now we're all set. Do you remember how to do that?
I can now just add across. So 10 plus 12 gives me 22. And then I always get stuck on the denominators. Do I add those?
No, the denominator stays the same in an addition problem. That's why we worked so hard to get them to 15. Now
so I just keep it as 15?
Yep.
All right.
You just add the tops.
And I'm done?
Well, you can have an answer of 22 over 15, but you also could make that into a mixed number.
Oh, we learned that last week.
Yeah.
Remember? Improper fractions. So if we look down here, we have 22 over 15, and we want to turn that into a mixed number, and I think we had to divide for that. So 22 divided by 15 goes in there ones, that's 15. I'm left with a remainder of 7, which means I get 1 and 7 over 15.
Beautiful.
And if you don't remember how to do this, look back at last week's video. So my answer is either 22 over 15 or 1 and 7/15. Should we check out another problem?
I think so. Let's try another. Oh boy, this one has 3 fractions to add together, all with different denominators.
Looks pretty tricky.
Well, let me try your method that I just learned of taking the biggest denominator, 10, and I'm going to skip count. So I start with, maybe I better do it up here, 10.
So all we're doing is we're finding the multiples of our biggest denominator.
20, 30, 40, that ought to be enough, probably 50.
I think so.
Okay, now, so I know that 10 goes into all those evenly because they're multiples of 10. Both of these have to go into the one we pick, though, don't they?
Evenly, right?
Evenly, yes. So 4 does not go into 10 evenly.
Nope.
But it does go into 20 evenly, because 4 times 5 is 20.
Perfect.
And we just said 5 goes into 20. Well, 5 goes into 10 2 times, but since 4 doesn't, we can't use that. But 5 does go into 20 4 times. So I think 20 is the number we're aiming for here in the denominator. I'm going to write those down. And then we'll figure out what the numerators are going to be.
Alright, so we have a whole long addition problem here. We want to make all of our denominators 20. I'll start with the first one, 1/4. Here we have 1/4. We have to multiply by some fraction to make it 20.
And that fraction has to be equal to 1, because you don't want to change the value.
We need to make sure that our numerator and denominator are exactly the same. 4 times 5 is 20. Whatever happens to the denominator is to happen to the numerator. So we're multiplying by 5. 1 times 5 is 5. And I got my first fraction done.
Beautiful. All right, I'm going to try the next one. 2 over 5. And it has to have a denominator of 20 after we multiply it by a unit fraction. Well, I think this 5 definitely needs to be multiplied by 4 to give us 20. And 4 over 4 is the unit fraction. So 2 times 4 is going to be 8 over 20. So we're saying 8 over 20 is equal to 2 over 5. So we can substitute it in here.
And again, we call those equivalent fractions when they are the same, but they look different. All right, last one. I am going to worry about 3 over 10. I'm going to multiply it by something to equal something over 20. 10 times 2. I got to multiply times 2 in the numerator because I got to, again, have a unit fraction here. 3 times 2 is 6. And I have 6 over 20.
Now, we could have actually put a 20 in the denominator for the answer when I wrote out those 20s in the denominator in the first place, because we know it has to stay. The denominator has to stay the same. But the tops we add together. So I would say 5 and 8 give us 13, plus 6 would be 19 over 20.
And that is our answer.
No way to reduce that.
Nope.
Beautiful.
Already in simplest form. Make sure that you clearly mark your answers. If you have any additional questions, come and see me during lunch. Hopefully this video helped you with adding fractions.
Bye.